Hi everyone, and welcome back to part 2 of creating genetic algorithm with neural network. In the previous video we created the Java application that handles the genetic algorithm and the neural network. Also it exposes the REST endpoints that we are going to use in this video. This video we will create the actual game with Unity and C#. I will start by creating the game objects we will need. First is the creature, and it will be a simple cube. I am adjusting the scale so it will work with default gravity. Also I will add rigid body and I will freeze rotation. I will add a tag for each game object I need to refer to from the C# scripts. Next I will create the obstacle and the floor. Also I'm gonna adjust the camera position and rotation to be the same as the current view. To do that I will click on the camera and I will click Ctrl+Shift+F. Now I'm gonna generate the creatures and obstacles from scripts, so I will move them to prefabs folder and remove them from the scene. Now I will create two C# scripts, one to generate creatures and obstacles, and one to control the creature. For the first script I will need to create an empty object to attach to it. We'll attach the Gen controller to the Gen manager object. And the creature controller to the creature prefab. In the Gen controller, I will need to have a reference to the creature and obstacle prefabs. On game start I will generate the first population. This method should call the first population endpoint we created in the previous video, but I will leave calling the endpoints until the end. And for now I will instantiate 30 instances of the creature prefab. I will spread the creatures on the x-axis, and I need the middle creature to be at 0 location. Generating obstacles will be very similar. I am setting the obstacle Y position to be half of the height of the creature, so the creature will not be able to go underneath it, and will spread the obstacles on the Z axis while keeping a distance of 4 meters between them. For the creature to jump, for now I will update the velocity of the creature rigid body when I press on a specific key. Since I am changing a physics property, I need to do it in the fixed update. The creature should jump, so I am setting the velocity to be the up vector and will multiply it by a magnitude. I am making it public so I can change it later from the Unity interface. Now there are two issues. I can jump while I am on air, and if creature is falling too fast, it will go through the plane. The second issue I will fix by changing the collision detection mode of the rigid body to be continuous instead of discrete. We can also have a private field for the rigid body component. To move forward, all I will do is add a forward vector to the current creature position. A forward vector is a vector pointing in the z direction, and I will multiply it by a speed that I will set as a public field. Also, I will multiply it by the delta time to make it independent of the frame rate. To only jump when the creature on the floor, I will check if the creature collides with the floor and set a Boolean field to true. When the creature stops colliding with the floor, I will change this Boolean field to false. And I will only allow the creature to jump when this on-floor Boolean is set to true. The creature will die when it collides with an obstacle, so I will add this condition here. Dying for now will just destroy the game object. Another thing we need to figure out is the distance between the creature and the next obstacle, because this will be the input to the act endpoint. I will create a private method to get the next obstacle. First, I will get all obstacles, and I will define here the closest obstacle variable that I'm gonna set to null. If the obstacle z position is smaller than the creature z position, that means this obstacle is behind the creature, so we should ignore it. If that's the first obstacle we find that's in front of the creature, I will set it to the closest obstacle. Otherwise, if this obstacle is closer than the closest obstacle, then I will update the closest obstacle variable. Next, I will create a method to get distance to next obstacle. This should get the next obstacle and subtract the z position between it and between the creature. Now I'm gonna create another method that will scale this distance between 0 and 1. This technique is called input normalization, and it will help the creature neural network to learn faster. To do that, I will first get the distance, and I will define a maximum distance the creature can see. Next, I will check if the distance is bigger than the max distance the creature can see to return 0. Otherwise, I will divide it by this max value to return values between 0 and 1. Also, I will inverse it so that 0 will mean obstacle is far and 1 means obstacle is close. Now, to make sure this is working, I will set the color of the creature to be between white and red, where white means the input is 0 and red means the input is 1. To move the camera with the creatures, first I will create a list of game objects to keep track of all creatures we generated. Now in the update method, I will get the first creature that's alive. Keep in mind that when a game object is destroyed, it will be null. Next, I will update the camera Z position to be the same as this alive creature Z position. I'm gonna also subtract it with 1 to move the camera behind it. There is a bug here. We should check if there is an alive creature first. To generate the next population, I will check if all creatures are null, which means they all crashed into an obstacle. And we'll call this new method. For now, this method will also call generate population method. And I will also update the start to call generate first population method instead. This will make our lives easier when we add the HTTP endpoints. I will create a new class to handle calling the REST endpoints. I'm gonna use public static methods for simplicity. To make an HTTP call, I will create a new instance of Unity Web Request class. I will give it the URL and the HTTP method. Then I will set the download handler to be buffer. And will set the content type and header to be JSON. Then I'm gonna send the request. Now if there is a network or HTTP error, I will log it in the console. Otherwise I need to parse the JSON response. So there is a JSON utility to do that. For this endpoint it will return population TTO. I will create in a second. Now to return the response to the caller, I will pass it to an action. An action is like a callback and it will be called after the response comes back and we parse it. We then have the ACT endpoint, but this requires a creature ID in the URL and the inputs as JSON object in the request body. This upload handler will send this string variable in the request body. This string variable will be the JSON object of the ACT input TTO. And this ACT method will return the ACT output TTO. Now there are a lot of duplication here, so I will create a method I'm gonna call post request. To use it, you need to define the input and output types, and we'll pass it the URL, the inputs which is the request body, and the onSuccess callback. Now we can use this utility instead in the ACT method. I will give it the URL, the input and the callback. For the first population we don't have an input, so I will pass an empty TTO that I will also create in a second, and it will be a class with no fields. Now for the next population and update fitness endpoints, I will create all the TTOs we used in the HTTP client. Each TTO needs to be serializable. The fields in these TTOs will match exactly the ones in Java service that we created in the previous video. Now that we have the HTTP client, I will start using it in the Jan controller. In the first population, I will call the first population endpoint, and on success I will pass the generate population method. So now this generate population method will accept the population TTO, which is returned in the response of the first population and next population endpoints. I will use the number of creatures from this population TTO. Also, I need to set the ID for each creature. To do that, I will update the creature controller to have a public ID field. And we'll set it here from the returned response. Okay, so there was an issue I was trying to solve. Since generating the first population is now asynchronous, the update method will be called multiple times before the creatures list is filled, and therefore the next population endpoint will also be called multiple times. To solve this, I will add a boolean is generating. That will be true while it is generating the first or next populations. And I will check here if it's not already generating, and only then generate the next population. I will call the act endpoint in the fixed update, and only when the creature is on the floor. Also, to not make the same mistake, I will check if it is not already acting. I will call the act endpoint with the creature ID, inputs, and will give it a callback. We only have one input, and we already defined it, which is the distance to next obstacle. Also, I will set here is acting to true. Now in response, I will set a class field here. To the next force we should act on the creature. It will be the response output multiplied by the up vector and the magnitude. And we'll set back is acting to false. In case the next force is not 0, I will set the creature velocity to it and will make it 0 again. I'm gonna call the update fitness endpoint when the creature hits an obstacle. After it successfully finishes, I will destroy the game object. The fitness will be the total distance traveled, which is simply the z position of the creature. That is assuming the creature starts from 0 position. I will power it to 2, This will make our selection algorithm give much more chance for creatures that traveled longer to be selected for crossover.